Okay, grade 11s. Moving on to topic 3.3. So we've got 2 reductions left before we start some practicing. So this reduction video is on what happens if we do 180 degrees plus theta. Now notice these start becoming easier and easier because we're actually repeating the same concept. So what I've done here is I've drawn theta, and again I've got r, which is the distance from the origin to the point. I've labeled the point with an x and y coordinate of a and b. And now what I want to do, exactly what we have been doing, is I'm going to reflect it into the second quadrant. So that made an angle of 180 degrees minus theta over there. But now that's not what I want. I want to do 180 degrees plus theta. So what I need to do is a second step of reflection, which is to fold this now line that I've drawn in directly over the axis again, this time the x-axis, making an angle of theta over there. So what angle have I formed now? Well, if I go anti-clockwise all the way from the origin all the way around, I now have formed the next cousin, which is 180 degrees plus theta. Now let's just think about it. Our r value would have remained the same. Our point P, well, this P, which we called P dashed, if you remember, was negative a, but your y value stayed the same. Now you've folded over the x-axis, so this x coordinate is the same as P dashed. Let's call it P dash dash. That might make a lot more sense. So my x value is the same as P dash. This time my y value is now negative b. So what we want to do is exactly what we did previously, is we want to look at the sine, cos and tan ratio of theta, and then the sine, cos and tan ratio of 180 degrees plus theta to see the relationship between these cousins. So if I look at theta, we've done this before. Sine of theta was b over r, cos of theta was a over r, and tan was b over a. So now let's look at this angle, which I'm now going to label in red just so we're clear where it is. Let's look at 180 degrees plus theta. So sine of 180 degrees plus theta will be the y value, which is now negative b over r. Cos will be the x value, which is negative a over r. And tan will be negative b over negative a, which I can simplify to b over a. Right, now let's look at the relationship. Sine of theta is b over r. Sine of 180 plus theta is still b over r, except we're now working with the negative cousin. So what's my first conclusion I can make? I can make the conclusion that sine of 180 plus theta is the same as sine theta because they're cousins, but it's the negative version. Now that makes sense because we're working in quadrant 3, and I know that sine is negative in quadrant 3. So this negative is arriving because we're looking at quadrant 3. Right, let's look at our next relationship. Cos is a over r when you're talking about theta. When you're talking about 180 plus that same angle, it'll be the same ratio but the negative cousin. So our conclusion from that is that cos 180 plus theta is negative, but it's still the same ratio as cos theta. And our last relationship is that tan of theta is b over a, and tan of 180 plus that same theta is still b over a. Now that makes complete sense because remember our all stations to Cape Town. So in quadrant 3, what do you know? Tan is positive. So our last conclusion is that tan 180 degrees plus theta is exactly the same as tan theta. So absolutely no worries about signs there because we're in the third quadrant, and so the positive cousin is there for tan. So those are our conclusions. Again, you kind of want to ask yourself, do I have to remember those? Don't worry. Once we've looked at all 3 after our next video, we're going to summarize and have a look at how you can figure this out in a second every time. It makes complete sense. Just note that these are both negative because it's quadrant 3. So let's look at some examples. It might make our life a little bit clearer. So this question again says without a calculator, which basically means I have to reduce everything down to a special angle, and then I can either use a calculator and cheat, which no one will know, or I can remember what our special angle ratios are. So we have tan 225. Now the question now should be, we should ask ourselves, is can I write 225 as either 180 degrees minus an angle, because we now know how to do reduction with that, or 180 degrees plus an angle. So both of those are acceptable. Notice you can't rewrite, you can rewrite 225 as 200 plus 25, but it has no help in terms of trig, because the only thing that can help us is if we stick to creating this angle using our symmetry. Now where is 225 degrees? Because which reduction setup is going to work for me? 225 degrees is there. So 180 would be all the way there, and now I must add an extra 45 degrees. So I can rewrite 225. I will rewrite it as 180 degrees plus 45 degrees. So notice I have not at all changed the meaning of the question. 225 is simply rewritten. Now we've just learned that when you add an angle to 180, that's exactly the same as tan 45. It's exactly the same ratio because of the symmetry. The question is it positive or negative? Is this a positive cousin or a negative cousin? And it's positive because tan of an angle is greater than 0 if that angle is in quadrant 3. And this angle is in quadrant 3. The angle of 225 is in quadrant 3. And so that's why this is the positive cousin for 45. Right, let's look at another two examples. Cos of 210, exactly the same question. Can I rewrite 210? Either as 180 degrees minus an angle, or 180 degrees plus an angle. And it's fairly obvious that it has to be 180 degrees plus an angle because this angle is bigger than 180. Now we can stop drawing pictures if we want. How do I rewrite 210? Well, it must be 180 plus, and that's 30 degrees. So I haven't changed anything. Now I know that this can be simplified. This has a relationship with cos of 30. So I'm not dropping the 180, it's not disappearing. I'm just saying to myself, oh gosh, no, I've learned that there are 4 angles in the Cartesian plane and they are all related to each other. And cos of 210 is actually related to 30 degrees. The question is it the positive cousin of 30 or will cos of 210 be the negative cousin? And it'll be negative simply because cos of an angle is less than 0 if that angle is in quadrant 3. And 210 is in quadrant 3. So 210 will have exactly the same numbers in their ratio as cos of 30, but it'll have to be the negative version of cos of 30. Finally, let's look at sine 240. Exactly the same question. Can I rewrite 240? And I'm hopefully realizing that there's no ways that I can rewrite it as 180 minus. So can I rewrite it as 180 degrees plus? And I can, because sine of 240 is sine of 180 degrees plus 60 degrees. So this will reduce to sine of 60 degrees. The question is it positive or is it negative? Now sine of 60 is a certain number, and this is related to sine of 240, except 240 degrees is in quadrant 3. And sine is negative in quadrant 3. So this is negative because it's in quadrant 3. Now let's go back to all these questions. Now that we have gotten these down to acute angles, which are special angles, we should be able to tell us what this equals to simply by using our special angles. So what is tan 45 equal to? Tan of 45 is 1. So tan of 225 actually simplifies to 1, and I can do that without a calculator because I can first reduce it to tan of 45 and then I can actually write that as a number. Let's look at cos 210. I first reduced it to cos of 30, in fact negative cos of 30, but I know what cos of 30 is. Cos of 30 is negative root 3 over 2. And finally, sine of 60 is also root 3 over 2, so this will simplify to negative root 3 over 2. So that's how I figure this out without a calculator. I first take my angle, and I rewrite it as 180 plus a special angle. Then I do my reduction, and then I can use my special angles, or I could actually just cheat on my calculator to figure out what sine 60 is if I've forgotten. Hopefully by the time you've done enough trig, you would have practiced so much that those actually just become part of your knowledge. Cool, that's our second kind of type of reduction. Now we're on to the third.